All right, we're going to get started by having you work through two opening problems where your task is to identify the slope of the given equations. Then I also want you to graph both of these equations or both of these lines on the same graph. You're going to do that for this top left slide and also for this top right slide where you do the same thing, identify the slope and then graph both lines. And that's going to lead us into what we're kind of investigating today. So hit pause, work through the opener. Like I say in class, all I need is for you to try these openers. They don't need to be perfect, but if you're just looking at what I'm doing, you're making this class a lot harder. So hit pause, work through the openers. When you unpause, we'll walk through what you should have gotten. Okay, so here are the lines you should have graphed. Both of these lines are in the form of slope-intercept or y-intercept, as a lot of you have been saying, where we're going to start by putting our starting point on the y-axis. So 7 is this, or this top equation is this line right here, where I'm starting at the y-intercept of 7, and then the bottom equation is this bottom line right here, where I'm starting at the y-intercept of -7. In both cases, the slope is 3, and something happens with these lines. They have a special relationship where they're never going to intersect, right? All these points are the same distance away. And the name for lines that never intersect is that they are parallel. One thing we'll take note of here in a second is that parallel lines have the same slope. That's what makes them never intersect, because we're always doing the same rise over run, just from different starting points. Okay, so that's kind of an introduction to what we're going to do with our lesson today. So we've got parallel lines where the slopes are the same. Then for the other equation or the other opener, we get a different relationship. Let's first talk about the graphs here. These equations are in point slope form, so I'm going to start by graphing or plotting the point 3, 4. That's that point right there, and then my slope of 1/4 going up 1 and over 4, making sure I have a positive slope line. The other equation has a -4 slope, and I'm starting at -2, -2. That's the point I circled here. And after I graph both of these lines, once again, we get a special relationship amongst them. That relationship is that these lines are forming what are called 4 right angles. Here are 4 90-degree angles. When this happens, the lines are considered to be perpendicular. Okay, and so part of our lesson today is how can we work with perpendicular equations? And again, it all comes back to the slopes. And so with perpendicular slopes, we're going to do two things to them. We're going to flip the fraction, so 1/4, if I flip it, turns into 4/1, and then we have to change the sign. So we have one slope that's positive and one slope that is negative. So the opener was just a way to kind of introduce these relationships of lines being parallel and perpendicular. We're going to get lots of practice writing equations of parallel and perpendicular lines, but we're going to start by having this note page, which should be used as you work through the notes and also the homework. So like with all of our lessons, this is kind of our key to how we're going to work through our practice problems. So here's what we need to know. Parallel lines are lines that never intersect. They will always be the same distance apart. The equations of parallel lines will have the same slope, but they need to have different starting points. Otherwise, they're just the exact same equation. So whether that be different y-intercepts, if it's in point slope form, a different starting point, they need to have different points, otherwise they're the same line. But the key part of that is that they are the exact same slopes. Now, perpendicular lines, they intersect to form 4 right angles. A right angle is one that measures 90 degrees. If you don't know what I mean by that, don't worry, that's something you'll get into more when you take geometry. For now, just know that it's a special relationship between two lines. Okay, so perpendicular slopes, there's two things that we need to do. We need to take the opposite. And when I say opposite, that means change the sign. So switch the sign. And then they have reciprocal slopes. And the reciprocal part is us flipping the fraction. So flip fraction. Okay, so we got to do two things for the perpendicular slopes. Switch the sign and flip the fraction. Okay, so again, this slide is kind of our key to how we'll work through the practice problems. And as you get to the homework, this is the slide that you should have out to help you to work through those problems. So go ahead and flip this page, and we're going to do just a quick practice with identifying parallel and perpendicular slopes. And with all these problems, the reading of the problem is going to be really important, because that's going to tell us whether or not we're working with parallel or perpendicular, and if we need to write our equation in a specific form. So for this task, we're just identifying what would the slope of a line that is parallel to the given equation be. So if I'm given an equation and I want to come up with something that is parallel to it, the only thing I care about is the slope in the given equation. I don't care about anything else that's in that equation. And if it's parallel, my new slope is the exact same slope for what I identified in the equation. Okay, so the rest of this doesn't matter. Okay, these equations, the only thing I'm pulling from it is the slope itself. And again, when it's parallel, the slope is the same. So now, when we do the perpendicular, once again, I'll identify the slope in the equation, so 3/4, -2, and -5/6. I do not care about anything else in this equation. All I care about here is the slope itself, and I want to come up with a slope that is perpendicular. So I got to do the two things that we talked about on the previous page, where I need to flip the fraction. So 3/4 turns to 4/3. This slope is positive, so my new slope is negative. -2 is not a fraction, but I can make it one by putting it over 1. So now when I flip it, it becomes 1/2. The original slope was negative, so my perpendicular slope is positive. Then I have -5/6. Again, if I take the perpendicular slope, that becomes 6/5. And it was negative, so now my new slope is positive. Okay, so now the only thing that we're going to add to this is we're going to full on write an equation. So we're going to be given a little more information. Again, we need to read the problem. That way we're figuring out whether or not we're working with parallel or perpendicular slopes. Okay, so here are some of the problems we'll work through. Our task is to write an equation of a line passing through the given point. So what I'm doing when there's a lot of words here is identifying the important pieces, kind of tell me what to do. So when I write my new equation, it needs to pass through the point that we are given here. That's just 1, 3. The equation we're going to write is parallel to the equation that we're given. So I see an equation right here. So all I care about is the slope, and I want it to be parallel. I'm going to write the equation in point slope form. Okay, which is nice because we're given a specific point. So my new equation in part A, I'm going to use the same slope from the equation I'm given. I don't care about anything else in here. This new slope needs to be -2, and it needs to pass through 1, 3. So that's y minus 3, y minus that y coordinate equals this new slope, which is the exact same slope for what we started with, and then x minus 1. Okay, so we take the same slope from the equation we're given, and we just make sure it passes through the given point. In the equation, I do not care about anything else except for that slope. So 1/3 is my new slope. It needs to pass through 5, 3, so that's y minus 3 equals that slope of 1/3 times x minus 5. Okay, well, I'm going to ask that you try number 4 on your own. Just like I said with the opener, all I need you to do is to try these. If you were just watching and seeing what I'm doing, you're making this class a lot harder. So go ahead and hit pause. Try your best with number 4. They don't need to be perfect, but see what you're able to come up with on your own. After you unpause, we'll go through what you should have gotten. Okay, for 4A, your new slope is 7/5. That's the same slope from the equation we're given. And then it's y minus 6, and then times x plus 3. Again, make sure when you're in point slope form, you're switching the signs of both the x and the y coordinates. Then for part B, my new slope is 6, which is the same from the equation we were given. I've got y minus 8, with 8 being that y coordinate, and then my slope of 6 times x minus 4, with the sign on that 4 is switched. Okay, well, there's some practice with our parallel equations. We're going to do the same thing, but now we're going to do these with perpendicular. So go ahead and turn the page. And again, let's start with the reading. Let's just not assume, even though we've done the parallel. We need to write an equation of a line that is perpendicular to the given equation and passes through the given point. Once again, we're going to write it in point-slope form because we're given a specific point. That way we don't need to figure out what the y-intercept needs to be. So I'm going to identify my slope of being -3. That slope of -3, I need to find its perpendicular slope. First, I'm going to make it a fraction by putting it over 1. So now when I flip it, it becomes 1/3, and the slope to start was negative. My new slope is positive. So the equation is y minus 3 and equals that 1/3 times x minus 1. Again, I don't care about anything else from that equation, just the slope of -3, and then it has to pass through the point of 1, 3. All right, part B. My slope in this equation is 3/2. I don't care about anything else there. So if I take 3/2 and I flip it, it becomes 2/3. The slope started as positive, so my new slope is negative. So that's y minus 2 equals -2/3 x minus 4. Okay, I'm going to ask that you all work through number 6. Again, just try. It does not need to be perfect. Go ahead and hit pause, and I'll have the equations written out for you once you unpause. Okay, so for number 6, I actually wrote this equation 2 different ways. First, starting with the slope, -1/5, we're writing an equation that is perpendicular. So I'm taking that -1/5, I'm flipping the fraction, making it 5/1, and I need to make it positive since my first slope was negative. So new slope is +5 or 5/1. And then this point, 0, -4, that's the y-intercept, right? X is 0, y is -4. So we could write this equation in slope-intercept form or the mx plus b pretty easily. It could be y equals 5x plus 4. Or if we just write it in, that's wrong, that should be 5x minus 4. Hey, if I write it in point-slope form where that y-coordinate is added to the other side, that would be y plus 4 and then equals 5x, or 5 times x. Then in part B, the slope is 9/7, so my opposite reciprocal is -7/9. It needs to pass through -2/7, so x plus 2, and then y minus 7. Okay, well, there's a little bit of practice from writing equations that are perpendicular. Now we're going to do a little bit opposite here, where we're going to be given a graph, and our task is going to be very similar. We're going to write the equation that is both parallel and perpendicular and passes through a specific point. So once again, read the directions, write the equation of a line that goes through the indicated point, write the answer in point-slope form. So in this equation, all I care about here is finding slope. Now to find the slope, I'm going to pick 2 points where the graph intersects real nicely. I'm going to find the rise over run. So slope here, the rise, I'm having to go down 1, 2, 3. And then the run, I'm having to go right 2. I'm noticing that the slope is negative, and I wrote it as a -3/2. So when I write my equation that is parallel, I'm going to use the same slope. For the perpendicular, we're going to take that slope of -3/2. We're going to flip it and make it positive. So the slope there will be 2/3. So my parallel equation here is y plus 8 equals my new slope, which is the exact same as the line that was graphed, and then x plus 1. So it has to pass through this point, and with parallel, needs to have the exact same slope as what we found. Perpendicular, just the opposite. So it's going to be y plus 8. So that part's the exact same, but now my new slope is the perpendicular slope of 2/3, and then x plus 1. So the only difference here is what we're using as the slope. Okay, let's do one more together, and then you're going to have a couple to practice on your own. But let's try this one more time. And notice that 0, 6, that is a y-intercept. It's saying write it in point-slope form, but maybe we do this one in both forms since we're given the y-intercept as well. So finding the slope, I'm going to pick 2 points where it intersects real nicely. I'm going to find the rise over the run. So m, or the slope here, is 1 and then up 2. So it's 2 over 1. So my parallel slope is going to have the same slope of 2. My perpendicular slope, I'm going to flip it and make it negative. So the parallel equation in its point slope form is y minus 6 equals 2 over 1 times x. If I want to write it in slope-intercept form, I recognize that that is the y-intercept. We could write it as y equals 2x plus 6. Okay, so both of those will work here. Since it says point slope form, this is going to be a little bit better. All right, then perpendicular, almost identical. We have y minus 6, but the new slope now is negative 1/2 x. And again, we could write it as y equals negative 1/2 x plus 6, where it's in slope-intercept form. Okay, you've got 2 more problems like this to practice. Even if they feel easy, I want you to try them. Again, just hit pause on the video, read the directions as you're going to do the exact same thing of identify the slope. Ooh, this one might be a little bit tricky. We need to make sure it passes through this point, and we need to do parallel and perpendicular. See what you come up with here, because this one is going to be, we got to think about this one a little bit more. Number 10 should be a little more straightforward like what we just did. Either way, pause and try your best with these. Okay, so number 9 is a little odd in that we want to pass through 2, 7, but our parallel line is just going to be another horizontal line. And so if it's going to pass through 2, 7, we need to remember, and it might actually help to write the equation here. This equation is y equals 3. For it to be parallel, it still needs to have a slope of 0. Well, for that to happen, it needs to be another horizontal line. And for a horizontal line to pass through 2, 7, we need the y-coordinate of 7 to stay the same. So the parallel equation here is y equals 7. Okay, those lines will never intersect. They have a slope of 0. The perpendicular line is one that is straight up and down and thus is vertical. And for it to pass through the point 2, 7, which it could maybe even help, could graph that point. That would be up off the graph a little bit. Would be this line right here, which is x equals 2. So a little bit harder because we're not really working with the slopes. Instead, we have to think about the relationship of a horizontal line in its equation and a vertical line in its equation as well. Okay, so again, the x equals 2 coming from that point and the y equals 7 also coming from that point. These ones are a little bit different than what we've discussed thus far. It's going to take a little bit of practice for us to get there. All right, but then 10, just like what I had done previously, our slope of the line provided is a, Ms. Younger made a mistake here because this is a negative 7/2. I should always check that I'm giving that negative slope there, but that's what's nice is that's an easy fix because my parallel equation needs to have the same slope of it being negative 7/2 and passes through the point negative or 4, negative 9, so that's y plus 9 equals the negative 7/2 x minus 4. But then for my perpendicular slope, if this is negative, my new slope is going to be positive. So I can make that positive by putting a plus sign there, making that y plus 9 equals 2/7 times x minus 4. Okay, well, thanks for watching. We are all done, and you can get going on the homework. Make sure you show the sub your filled in notes, and have a great rest of your day.